Okay, G, now let's continue from where we left off. One thing I want to add to this term machine dependent, because often there's a word that goes around in your exams as well. It is known as portable or non-portable. So if we're looking at something that which is actually the same in all architectures, that would consider it as a portable language. Whereas if it's not, it's machine dependent, then it is non-portable. We'll be looking at that in a bit when we're discussing high level languages. Okay. Now let's talk about the language translators. As mentioned before, we have three language translators. We have the assembler, and we have the compiler, and then the interpreter, right? Now, the thing about assembler and compiler versus interpreter, there are some similarities in all three of them, some differences as well. It's quite interesting. First of all, the major difference between your assembler and compiler and interpreter is that assembler is only dealing with low level translation, whereas compiler and interpreter can handle high level language translation. That's the biggest difference there is. Okay. Apart from that, now let's look at some similarities amongst these three. Assembler and compiler create something that is known as an exe file. So we'll be looking at that in a bit, but exe file is not created in the interpreted environment. So that is the similarity we see between assembler and compiler. And then we see some similarities between compiler and interpreter, which is of course being that they are both related to high level language translation versus assembler is only dealing with low level translation. Okay. Now, as mentioned here, it is used for converting low level machine languages to machine code only. One more thing, since as you can see here, machine code is not actually that easy to write in. Now, if you look at it, I just did one task here. I added two numbers and stored in the third number. That is a very simple task. Even for this simple task, I will have to write three statements assembly language. So that what that shows is that assembly language, even though being an improvement on machine code, is not necessarily that easy to work in. It results in greater amount of lines, greater code. That is one problem that we are dealing with in low level language. So, okay, I understand that it is very easy to say that, okay, at that time in the past, when we were still evolving as programmers and languages were still evolving, assembly language was a huge jump from your machine code. I understand that. And then eventually, when we got high level languages, assembly language became obsolete. So that means assembly language is not being used anymore, right? No, that's not true. Assembly language is still being used. And even today, assembly language has its important applications. Now, what possible situation could it be that assembly language becomes inevitable? Well, first of all, assembly language, since the translation process is very fast, they are very they are very fast in execution. And in fact, translation and execution, in which case they do not require a lot of resources for running. And the reason that they're fast in translation is because they're already near machine code. So the translation process is not necessarily that time consuming. So yes, you can say that they are very fast in translation and execution, and that's why they're still currently being used, because of their lightweight and not being that resource hungry. Secondly, if you want to test or develop certain hardware, assembly language is where to go. Assembly language allows you to control hardware directly. High level language code does not allow you to interact with the hardware. Assembly language code has instructions that simply you can in assembly language code, you can directly access specific memory locations. You can directly interact with certain registers, so on and so forth. So that means if it gives you more control, it gives you more control over the hardware. So if the problem that you're trying to solve requires you to interact with the hardware directly, in which case it's possible that you're creating new hardware, testing new hardware, developing new device drivers, whatever, in which case you will have to be working for assembly language. So that what that means is that today, even today, there are applications where assembly language is still being used. So it's very much in demand right now as well. So this is the benefits of using assembly language, right? Okay, now assembler, as mentioned before, does whenever you write, now let's talk about the translation process, right? Creates an exe file. Exe file means machine code file. Exe stands for executable machine code, right? Executable machine code. So it creates an exe file and it translates the entire assembly assembly code in one go. The program assembly language program can run again repeatedly without reassembly. So basically, I don't need to translate it again. Once I have created the exe file, I can run that program again and again just by the exe file alone. I do not require the reassembly process. Secondly, if there is an error, syntax error. What is syntax error? I'll discuss in a bit. If there's an error, the code will not run at all. So it has to be completely error-free for assembler to run this code, right? And if you are working on a program for general distribution, okay, so just if you're working on a program for general distribution, and by that means you want to just sell your software without sharing source code, then assembler should be used. So if, for example, you are worried about sharing your source code and you want to, just share only the exe file, then you can use assembler. You should use assembler because assembled programs create exe files, and exe files can be run many times, as many times as you need without reassembly, without having to have the source code, right? And secondly, the reason that we're still working on assembly language code, you're using assembly language today, the benefits of using assembly language now, because in paper, you are often asked this question, what are the benefits of assembly language today? In that case, the benefits are that you are allowed to work on, say, for example, a specified hardware. You're allowed to create new hardware, test new hardware. Assembly language gives you more control over the hardware. So if any of the problems that you're trying to solve require this, then the assembly language is the way to go. Now let's talk about compiler, right? If compiler is used, it translates high-level language code into machine code, and you get exe file in one go. So you can say that the entire high-level language code is translated into machine code in one go. So if since it creates an exe file, the translated code or the compiled program can be rerun many times without the need of recompilation or source code. So you don't have to share the source code for the code to run. If you want someone else to use your program, you can simply compile it and just share the exe file. And recreating source code from the exe file is a completely separate thing. You can't do it. So anyway, now moving on. Source code or compiler is not needed for rerunning the program. So therefore, you can say it is used for general distribution of software. So if you're in the business of software purchasing or selling, you will definitely be working on a compiled environment because you don't want to share your source code. Your source code is your property, and you just want people to use your program so they will have access to exe files. Okay, one thing you need to be clear about compiled program is that if you know, I'll generally summarize what happens here in the compilation process. Okay, the compilation process takes the following steps. Step number one, the first line in source code, a line in the source code is read and analyzed. And second part, okay, by the way, analyzed for what? For errors. Syntax errors, by the way. If there are no errors in the current line, the compiler will move on to the next line. The process, if there is an error, the compiler makes a note of the line number of where the error was found. अब यहाँ पे एक बात है, there's one thing that we need to understand here is that compiler can say that may not run at all. In which case, even if it finds a single error, right, then it will not run at all, right? So if in the above steps 1, 2, 3 are repeated for all the lines of the source code. In the above steps, there are two possibilities as outcome. One, that there is even a single error. There is some error in the source code, in which case the outcome of the compilation process is a report stating the line number of where the error is and a possible solution. Remember that the compiler is an expert in highlighting or any language translator is an expert in highlighting the syntax errors. It knows the syntax perfectly. So if there is some syntax error, it should be able to highlight the line number and also give you a suggestion, a possible solution to solve the syntax mistake. So it gives you a solution that is missing, semicolon is missing, comma is missing, something like that, right? Okay. Now, the second possibility is that there are no errors, in which case the outcome of the compilation process is an exe file, which means that the code has been successfully translated. And now you do not need to carry out this compilation process again. Now you simply use the exe file for continuing use of the same program. Okay. Now let's talk about the interpreter. It also translates high-level language code into machine code, but it does it one line at a time. So source code has to be present. For the code to run again, it is best used for testing code while it is being developed. Now, one thing is about compiler is that if you do not write the complete code, if you don't finish it like it's supposed to be finished, it is considered as a syntax error. All programs have a proper way of starting a code and ending the code. So if you don't end it properly, that will be considered as a syntax error, or do not start it properly, it will be considered as a syntax error. So let's just say you just wrote a few lines and just want to see if those few lines work properly, and you didn't end it properly because you just wanted to write 2 lines. The compiler would not be able to run that code because not ending a program properly is considered as a syntax error. However, interpreter is not the same way. Interpreter will run even if a single line that you've written. It will run it. It will simply read that line, analyze it for syntax errors, and run it if it's correct. So when we say that we want to write and test code on the go, say I wrote 3 lines and I will see if the 3 lines work properly, and I want to write the rest later, but I just want to see if the 3 lines work properly or not. Interpreter is a good way to do that. Compiler becomes difficult. You have to complete the code properly. You have to write code stubs to complete the filled in places, and it takes a long time. But interpreter is very easy to do. You just write 1 line, you can test it. You write 2 lines, you can test it, and it gives you the result right away. So it's best used when you want to test code as it's being developed, right? Secondly, now we've mentioned that source code has to be present for the code to run again. It's translate high-level language code into machine code, one line at a time, right? Secondly, we can say that let's go over the benefit of working with interpreters, that it allows us to test code while it is being developed. We don't have to complete it all the way. Now let's go through the translation process, or how the steps involved in interpreted. Okay, the first thing, the first line is read, analyzed, and analyzed for syntax errors. and run if it is correct. So right away, first line is picked up, is right away executed, right? Then the same process is repeated for all following lines. The execution process stops when either there is a line that has a syntax error, or there are no more lines to run. So when we say compiler, if there is a syntax error, the code will not run at all. Whereas for interpreter, the code will run till the line with syntax error, and execution will stop. So the lines before the error line will be executed, and as soon as the error line comes up, execution will stop right there. So the statement that code will not run at all does not apply to your interpreter, whereas it works for the compiler as well as the assembler, right? Okay, so I'm pretty sure that we have covered where the differences between assembler, compiler, and interpreter, right? And we just quickly summarize it here, that assembler is translating low-level language code to machine code. It creates an exe file, so basically you do not require reassembly to run the code. Assembly language is difficult to write. Why do we use it today? Even because that we want to work on hardware, create new hardware, test new hardware. It gives you more control over the hardware. That's why you have to work with assembler, right? Secondly, if there is some sort of syntax error, it will not execute at all. It will simply halt. And it is used for general distribution because you don't have to share your source code. You just create the exe file once and you can distribute the exe file without having to share your bread and butter, your source code, right? Now, the same thing applies, the same concept as assembler, but the difference is that if you want to do the same things with the same facilities with a high level language, you're talking about if you're talking about a compiler. Now, what a compiler does, such as a say compiler for C++, it allows you to compile the entire code in one go and translate it into machine code exe file. Now, every time you want to run that program again, you don't need the source code or retranslation process. You can simply just execute the exe file and the code will be running in front of you. So again, this is also an example of a translator that can be used for general distribution of the software, right? Now, the way that your compiler deals with errors is kind of different as compared to interpreter. Compiler reads one line, it analyzes it. If there's an error, simply it will move on. If there's an error, it will keep record of it. If there is no error, it will move on to the next line, analyze it. If there's no error, move on to the next line. And it will simply go through this exact same process for all of the lines of the source code. After it has read all of the lines of the source code, one of two possibilities may occur. Either the code will run, an exe file will be created, in which case that means that there was no syntax error. However, there is even a single syntax error, the code will not run at all. In fact, after this entire translation process, you will be presented with a report stating which line has that error. And since the compiler has a very good knowledge of the syntax, it will always also provide you with a possible solution to this particular mistake that you have made. Simply, moving on to the interpreter. Now, if you have interpreter, you are also dealing with a high level language, just like your compiler, but the difference is that now your translation takes place line by line. So what happens is that I will pick my translator, my interpreter will pick up one line. By the way, a good example of interpreted language is Python. You will pick up one line and you will translate it and you will analyze it for syntax errors. If there's no syntax error, simply execute it right away. You'll pick up the second line and you will translate the exact same thing. If there is no errors, you will execute right away. And you will repeat the entire process for all of the lines, and your process for this interpretation will stop only in one of two situations. One, that I have no more lines to execute, simple, so my entire program is finished. Or two, that I have encountered a syntax error. So as soon as I find out the line that is wrong, my execution process will halt right there. So before this line, everything was running all right. But as soon as that line, and I encountered that line that had a problem, I will stop right there, right? So as far as this statement goes, that code will not run at all, that does not apply to an interpreter, because it will at least run the lines before the problematic code line, right? Before the error encountered, right? Finally, for interpreter, if you are working if you want to test the code while it is being developed, so interpreters are going to go compile it. It makes it difficult to do. Interpreter, you can write one line and test it. You can write two lines and test it. It's very easy to use. But interpreter has one very major drawback, that if you want to, for example, enter the business of software distribution, interpreter might give you a problem, because you will have to share your source code for the interpreted code to work. It is not created in a C file. That's why you will have to share your source code every time interpretation will take place for the code to run. So it's not necessarily recommended for general software distribution. Now, finally, let's talk about the different types of errors. There is one syntax error, then there is your logic error, and then finally there is the runtime error, right? This third type error is not part of your syllabus, but still give you some knowledge about it. Syntax error is that there is a mistake. With the rules of the programming language being used, because of which the code will not run. So for example, you're writing Python, for example, Python, for example, Python, instead of doing A is equal to B plus C, you do something like this, which does not exist in Python. It will generate some sort of error. So that is a syntax error. If the code will stop, it will not run. Or possibly, say, for example, I'm using an if statement. If you're familiar with this, if A is greater than B, I'm supposed to give a colon here. Say, for example, if I forget this colon, that would generate a syntax error. The code will not run, right? So it's a mistake that is generally linked with the violation of the language rules, right? Now, secondly, we've got logic errors. Logic error means it is also known as a bug. The code does not perform as expected. So it means that it runs it completely. Because it's running completely, it's safe to say there is no syntax error. It produces a value as a result, but the result is not what was expected from the code. You were expecting the outcome of 10, you got 9 for some reason. That's a logic error, right? Now, the thing is, syntax errors are very easy to eliminate, because as mentioned before, your interpreter, language translator, whatever you're using, highlights the line number for you, and in fact suggests what went wrong, gives you a possible solution, because it has a very good knowledge of the syntax. However, logic errors and bugs are difficult to find, because you are in control of what the possible outcome should be. The translator does not know what you were expecting. The translator does not know that you were expecting an outcome of 10. You know that. And since it doesn't know it, it can't help you. You are a better judge of how your program should be performing. And if it's not performing like that, you have to solve that problem yourself, right? Finally, a runtime error. A runtime error is quite different. It is not a syntax error because the code does run for some time. And it is not a logic error because it doesn't run completely. Logic error runs completely and produces a value. It's only then that I realized that the value is wrong. So it's a difference between both. Syntax error does not run at all. Logic error does run but produces wrong value. Runtime error runs but does not run completely and crashes in between. Code crashes, suddenly stops because of some value that cannot be processed. Now, for example, you wrote a code that takes two inputs and a division as two inputs for a division, right? So the first line asks you to put a number A. The second line asks you to put a number B. And when, say, for example, you put the number A, you gave a value 5, and for B, you gave a value 0. Now, the third line of your code was supposed to do A divided by B. Now, as you realize that A divided by B would mean that 5 divided by 0. And we also know that anything divided by 0 is not possible. It's a math error. Now, because of this, my code will crash. Now, it was running. It took two inputs from me, and it almost started performing the division. So the code was running, but suddenly it dropped because it had a value that it could not deal with, which is division by 0. So this is a runtime error. The code crashes in between, right? Finally, IDE, last and final topic of this chapter, IDEs. IDE stands for Integrated Development Environment. And it's basically where is the environment that you will be using for your code development, right? It provides you tools for code editing and execution. And depending on the type of IDE you're using, it also provides you different features such as error checks, runtime error checks, debugging windows, so on and so forth. But basically, the general purpose of all IDEs is that it provides you an environment for where you can write the code and also provides the backend translation software, namely the compiler and interpreter, that executes the code. And depending on the type of IDE you're using, it can add further features such as runtime syntax checks. So it just, as you're typing, it gives you it underlines what mistakes possibly you have made, so on and so forth. So this is the role of IDE as per your syllabus. So this is the end of the chapter, and let me know if you have any questions.